Cool. All right, my friends, it's good to see you. I wanted to just run through one assignment. So if you have your notebook with you, would you get out page 135? If you don't have it with you, get out a sheet of paper, please.
Why do that? That's going to be
Cool. So do I really want to change a new trend?
Jason, in the crowd.
135, please.
Okay.
Page 135. No. We're going to look at it. We're going to kind of go through it a little bit. And then you guys asked, what is our final exam worth in here? It is worth 15% in Algebra 1. I think it's 15.
Is that what you gave out?
No, I didn't give anything out. I'm just... So, while we're talking about, let's just talk about grades real quick. Let me get to this end of this. So, we have 3 weeks of normal classes, then we go into final exam week. You all know that? Okay, so what will your grade look like in 3 weeks? Well, let's think about it. Are we most of the way through the content in this class right now?
Yeah.
So honestly, if you keep doing what you're doing, so let's say you have a 78.7% right now.
Are you serious? That's legit me right now.
That's what you got right now?
That's a prime example.
Oh, okay. Well,
It's like exactly my grade.
I just pulled it out. Well, good. You can follow along on this. So if this is truly your grade, you have to think about this. So your semester work,
Someone came.
your semester work, that's everything you're working on now, right? That's going to account for 85% of your semester grade. And then, whatever you get there, we're going to have a final exam. And your final exam is going to be 15% of your grade. And then, your semester grade is going to be based on, 90, 80, 70, 60 grade scale. So somebody who has a 78.7, should they want to get the B or the C? Well, I think most of them would say I want the B. Okay, so they want to get to the 80%, right? Anyone stuck on this? Everett, will you grab me a calculator? Just toss it up to me, please. Thank you. Yeah, it's a school one, so if it breaks, we'll get one. Just kidding. Yeah. All right, so let's do this actual math. So I'm going to take this 78.17, and I'm going to multiply that by 0.85 plus, we're going to call this x. We don't know what this is, so we'll call this 0.15x equals 80. Is that okay? And the reason I kept the 80 as that is because I had the 78.7, our given grade. So let's do the math on that. So 78.7 times 0.85. So just doing the other arithmetic here. All right, Algebra 1 folk. You want the B. How do you solve that for x now? Minus 66.895. Subtract 66.985 from 80. So that comes out to 113.105. How do I solve that for x? Divide by 0.15. So right there, I mean, do you think that would be a legitimate goal if a student had a 78.7 to say, hey, I want to try and get a B? Does that make sense? Like if the kid has 64% says, dude, I want an A. Hate to tell you this, you ain't gonna get there. But the 78.7, you truly could get there, right? But you have to score an 87.4% on the final exam. Is that possible to do? Absolutely. The nice thing about final exams is this. Well, it's got a positive and a negative. The negative part of a final exam, it's kind of everything you learned for the entire semester. You're like, dude, are you kidding me? Well, no, I'm not. But we're not going into real deep detail on the concepts. It's like, if we had two-step equation for you to figure out, you might have 2x plus 3 equals 8. You're like, dude, I could do that. I know you can. There was other multi-step equations that we did that were much deeper in thought when we were originally working on them. So, but here's the fun one. So you're gonna get the kid that says, dude, I got a 78.7. All I want is a C. You know that kid? Right? So that means I'm gonna make this a 70, and let's solve it from there. So I'm just gonna change the math. That being so it'll be 70 minus 66.895, which then changes this score here to a 3.105. And then if I divide that by 0.15, so that kid's like, dude, I just want the C. Needs to get about a 21% on the final exam to keep the C.
What are people's average grades on this final?
Huh?
What's the average grade on final? Like, what's the percentage?
Like,
I mean, they're
like how do people normally do on CP Algebra 1 final?
Yeah, like, would it be a 20%, or would it be
I have gotten scores that low, yes. And then their parents are like, hey, what did they do wrong? I'm like, everything. It's like, well, they need to have A's. They want to go to Harvard. And then I have to actually break the news to parents saying, I hate to tell you this, but your kid isn't bright enough to get into Harvard. I mean, it's the truth. It's the reality. But people know they're going to go to Brown University. No, they're not. And it's okay. Because a whole lot of other people don't go to those schools too, and they do just fine in life. Right?
Yeah,
I mean,
so what's the average grade?
I would say the average grade on the final in here would be between a 75 and an 85%, somewhere in there. Yeah, I mean, it's not an impossible test. We're not trying to say, dude, let's make this drop your grade. We're trying to say, hey, we want you to show us what you know. Do the best you can on it. Don't turn it in blank and expect sympathy. I'll tell you that. Which I've had that before. Hey, what can I do to make this up? Well, take it again next year. No, you're a mistake.
Wow, we're almost halfway through this grade already.
All right. Yeah, actually, first semester is a little tiny bit longer than second semester, so we might be pretty darn close to. Can't wait till summer either. Best stuff ever.
Are you gonna throw ragers?
I know.
Joe's gonna go on a straight 5-day bender.
No, probably not.
Just drink and drink and drink.
No.
Apple juice.
All right.
Poetry.
So before we went on our Thanksgiving break, we talked about graphing two lines. Agree? And then we saw that, if you graph two lines, there's something that could happen where they cross each other, which gives you one solution. Agree? But we also found that graphing isn't the nicest because it's easy to make errors on it. There's other things that could take place. We could take and have two lines that are parallel to each other. Do parallel lines cross? So this has zero solutions. And then there was that one last strange category, which people kind of look at you going, you got what? And it's when you have the exact same line on top, and this actually means you have infinite solutions. Okay, do you recall that?
Yeah.
So that's basically where we're starting to pick up, but we have to realize that I am freehand drawing graphs, and when I freehand draw graphs, what could happen? That could be messy, right? I'm not a pro. I don't have this magnificent, straight, steady hand. I've got all the classic examples that most 47-year-old guys have. My thyroid doesn't work anymore, so I got to take thyroid medication.
Really?
Yeah. Thyroid is this little tiny gland that sits right here. It actually controls, it has a lot to do with how your skin is. So if you have dry skin versus oily skin, that's one of the functions of it.
Do I have a thyroid?
Does everyone have a thyroid?
Yeah.
But not everyone has one of those things that the
Tonsils?
the hernia, right?
A hernia?
I don't know what that is.
No, you get a hernia by tearing something in a region in your body. Yeah, you don't want there.
That's what that is. My parents are always like.
No, but you get a hernia like right here.
Okay.
Like if you broke a rib, you could easily get a hernia, and that basically means your insides are starting to push through your
I know what that is.
push through. I mean, so a lot of times you can get your intestines stuck, and it can start poking out.
Right.
And why do your intestines come out of a hernia? A hernia is just a hole that's not through your skin, but it's in the sac underneath. So like if you sneeze, something comes out, and it's like, dude, what the heck is it? It hurts. It stings. It feels like fire. But they have to fix it. You can't just cure it. Yeah. Oh, I forgot you, didn't I? I'm sorry.
Well, everyone for this thing.
So you don't want a hernia. It's not the thing we're going after. All right, let's take a look at these notes I just handed out to you. I think you all got them now. Am I right with that? All right, so we're just kind of warming up. It says evaluate 5a plus 2b if a equals 4 and b equals 3. So I'm going to take 4 and plug it in here. I'm going to take 3 and plug it in here. So I get 5 times 4 plus 2 times 3. And that's going to give me 20 plus 6, which is 26. Is that okay, maths? And then we're continuing to evaluate. So I know that x equals -3, so I'll plug that in there. And y equals 0, so I'll plug that in there. So I get -2 times -3 plus 2 times 0. -2 times -3 is positive 6 plus 0, so that's just positive 6. And again, if you're just plugging in, you have a variable, you know what it is equal to, you can just plug it in. So this one I know that m is equal to 2 and n is equal to -1, so I have 2 times m squared times -1. 2 squared is 4. 4 times 2 is 8. 8 times -1 is -8. Is that okay? And then it says, hey, we're going to warm it up by solving by graph. You know, we talked about this a little bit. So this one has y-intercept of -4. And then I'm going to go up 1 right 2. So that line looks like that. And then this one, I could probably do the cover method. So x equals 3. Y equals -9. And make them cross. This kind of looks like they cross about here. So I'm thinking 2, -2 is where they might cross. And then how can I double check if that's right? I can plug them in, right? So +2 is an x value. The -2 is a y value. If you plug them into both and they work, then great. So if I plug it into that, I get -2 equals 1/2 times 2 minus 4. So -2 equals half of 2 is 1 minus 4. -2 equals -3. What can you tell me about that? It's wrong. So my graph is off a little bit. I'm not seeing where it necessarily worked because I freehanded. I didn't do it perfect. Okay? So do these two lines indeed cross somewhere in this region here? I think so. Do I know exactly where they cross? Well, I don't know, around there someplace. So that's why solving by graphing isn't a real awesome way to do it. Okay, so we're going to talking about using substitution. And substitution is going to allow us to do for us what graphing did. It's going to allow us to get accurate answers. The answer we get is the intersection point if we had graphed it really skillfully, okay? So, if we're going to solve by substitution, it says solve by substitution, do we know anything about x or y? Well, yeah, we know. So this is our system we're using. So we have 3x plus y equals 2, which is some line. And then we have y equals 5, which is a horizontal line through 5. And so they would intersect because they have two different slopes. Okay? So do we know anything about x or y? Yeah, they told us that y is equal to 5. The great thing about it is they already gave us half the answer. We know the y value is 5. Okay? So I'm going to take y equals 5, and I'm going to plug that 5 in for y on the other equation. So this is going to get plugged in right there. So let's bring this down. 3x plus, that was a y, but I'm going to put a 5 right there. And then you have 3x. Subtract 5 from both sides, so I get negative 3. So x equals negative 1. So if I had graphed these really well, I would have seen that it would have crossed at negative 1, comma 5. Okay? So substitution, you're trying to see if one of them directs you to say, hey, this is what one of the answers will be, and here it is. Can you guys excuse me a sec? I just want to have a sip of water.
Snake in the bathroom. It was just my
Oh.
You're right, I'm watching.
I just record the whole time so I can hear what you're saying. Are you serious? So I am. All right. Any questions on this first stuff? Can I move on? Can I go? Yay. Let's do it. All right. So let's change it a little bit. So we have two linear equations. We have y minus 3x equals 7. And then we have x equals y minus 1. So do we know anything do we know if we have an x equals or a y equals up there at all? Is there an x equals anything or x equals what?
Y minus 1.
Yeah, so x is equal to y minus 1. Everyone feel comfortable with that?
Yeah.
Is anyone like, I don't know where that came from? So then what we're going to do is they didn't give us one of the answers right off the bat. We're going to take this, and I'm going to plug it into the x on the first equation. Okay? So let's bring me down this first equation. So I get y minus 3 parentheses equals 7. What had been where that parentheses was? What letter was there? X. What's going to go there now?
Negative 1.
Almost. Y minus 1. Okay, because x was equal to that. So now I'm going to have to go ahead and work this out. Well, I can distribute negative 3 over here and here. Is that okay? Did I do my math okay? Negative 3 times y is negative 3y. Negative 3 times negative 1 is positive 3. Is that okay?
Yeah.
Let's combine some like terms. That's going to give me negative 2y plus 3 is equal to 7. just show the work. Subtract 3. So what's 4 over negative 2? Negative 2. So I have one part of my answer. What do you think I should do with that y value with either of my equations? Plug it in. Is there one equation that serves us better? Like what letter am I looking for right there? What letter is that?
X.
X. Were any of my equations x equals?
Yeah.
Which one, the first or second one? Second one. So this is x equals. It's directing us to it. We could do either equation. It's going to be the same answer, but sometimes there's one that's going to lead you to it a little bit better. What do we know? Right now I know that I have x equals, that's one of my originals. What did I just solve for? What letter did I solve for?
Y.
I solved for y. So what am I going to plug in for that y value right there? Negative 2. And negative 2 subtract 1 is negative 3. So the solution to this problem is negative 3, comma, negative 2. If I had graphed it, it would cross at negative 3, negative 2. So this leads us to answers with a little bit more work than graphing, but sometimes graphing takes away a lot because graphing, you can't always see it as well. Is there any part of this that there's questions about? Feel comfortable? I don't know. Can I move on?
Yes.
Okay. All right, so we have a couple here. So let's take a look here. I know that y is equal to this. So what am I going to do with x plus 2? Plug it in for y on which equation? Top or the bottom? Top. So this is going to go in for right there. So I have 2x minus 3 parentheses equals 2. What was where those parentheses were? X plus 2 is going in for it, right? Because that was what y equals. So this right here, I'm going to plug in right there. So I'm going to get x plus 2 right here. Does that seem to make sense? Can you make that work in your mind?
Yeah.
Okay. So remember, I'm going to distribute, and I have to distribute the negative 3 to both. Take a look at these signs. Are you okay that those signs are both negative? Does that make sense? Because I distributed the negative 3 over both. Okay. Combine like terms, so these are like terms, so I get negative x minus 6 is equal to 2. What should I do next to start getting x by 6? Add 6, I like it. So negative x is equal to 8. So what's x have to be equal to? Negative x is equal to negative 8. Good. So I get my x value as negative 8. How do I get my y value? Yeah, so I'm looking for that y value, right? If I go back to my equation and I want to look for my y value, I can plug it into either of my equations, but does one of them kind of say, hey, y is equal to this?
Yes.
Which one, top or bottom? Bottom. So this one says, hey, y is equal to x plus 2. Well, I just found that x is negative 8. So sweet, I have y equals x plus 2. I'm going to take negative 8 and plug it in. So negative 8 added to 2 is negative 6. So my solution to this problem is negative 8, comma, negative 6. Any worries on this one? Seems okay. Okay. Can I move to the I think it's only one more I have to do, right? Let's see about that. Yep. Cool. One last example.
Oh, really?
All right, so let's use a little bit of logic. Our first thing is, yes? So the first thing we're looking at is I have two equations. Everyone agree? One equation is 3x plus 6y equals 12. The other equation is x plus y equals 1. So does one of the equations say x equals or y equals? Anyone? I have x plus y equals 1. That's pretty close to having x or y equals. It's not exact though. So let's do this. Pick a letter, x or y. Your choice. Y? I heard it. Alright, so we picked y. I know you picked x. It still works the same way. So I'm going to just modify this equation to look like this. What did I do?
1 minus x.
I just subtracted x from both sides, right? So now, do I have one of my two equations, 3x plus 6y equals 12, or my modified y equals 1 minus x? Do one of them say x equals or y equals? Yeah, the new modified one says y equals 1 minus x. If I had solved for x, I could have had x equals 1 minus y, and it would work the same way. So now, what am I going to do this? Plug it in where? Which one, top or bottom one? Top one. So I'm going to take that, I'm going to plug it in right there. So I'm going to have 3x plus 6 blank equals 12. What was where that blank is? Y. What am I going to put there now? 1 minus x. Love it. So I'm going to distribute here and here. So now I only have x to worry about. Combine my like terms. So 3 minus 6 is negative 3x plus 6 equals 12. Subtract 12, or excuse me, subtract 6. And then divide by negative 3. So I get negative 2. So my x value is negative 2. Now I have to find my y value. So I have an x value I know. I have a y value that I'm looking for. Is there an equation up here that I have where I can plug in x and it says, hey, y is already equal to this? The bottom blue one, right? So if I take that and plug it in right there, I could plug it in here too. It's going to be the same answer. But that one's already y equals, and it says, hey, I want to solve it. So y equals 1 minus x. Y equals 1 minus x. Right? That was the equation from above. Did I do that right? Okay. And I know this to be an x value, so this is going to get plugged in right there. What's 1 minus minus 2? 3. So that's my solution. So if I had graphed these, I would have that stuck out. Now, where substitution really works great and graphing doesn't is, what if I were to had graphed it and my intersection was like 5 over 7, comma 3 over 4? It's kind of hard to look at a graph saying, it's 5/7 and 3/4. That's pretty good. So, all right. So for our opportunity for next time, could we do this? So what I'm going to do is, hey, Spotify, dude, sweet. That came up. All right. I think we can do this, and this isn't going to upset the system of people too much. I would like to do page 137, 137, and 138. And this is where a lot of you are going to get all mad. Let's just do the evens. You're like, dude, do I have to do all of them? And then you get the kid, hey, which ones are the evens? And I say, just do them all, and I will ensure you get the evens. So 2, 4, 6, 8, 10, 12.
Will we get extra credit if we do the odds?
If you did the odds in lieu of the evens or did them both?
If we do them all.
Do you want extra credit if you do them all?
Yeah.
Yeah.
Okay. Maybe I would put that into a consideration of that I would bump your grade if you did it. Sound good?
Yeah.
Did everyone have a nice holiday?
I had an amazing holiday.
Good.
It was amazing.
Good.
Okay, I'm responsible for people.